Hello everyone. Let us see next example. If alpha and beta are the roots of the equation z square sin square theta minus z sin 2 theta plus 1 is equal to 0, then we have to prove alpha raised to n plus beta raised to n is equal to 2 cos n theta cosec raised to n theta. Now consider the given equation z square sin square theta minus z sin 2 theta plus 1 is equal to 0, which is a quadratic equation in Z. We have to solve this by our usual formula, that is value of a is z square coefficient sin square theta, value of b is with sin minus sin 2 theta, value of c is plus 1. The formula is minus b square minus 4ac upon 2a. Put this all these values in this equation, we get this 2 sin theta sin 2 theta formula is 2 sin theta cos theta, and b square is sin square 2 theta minus 4ac is this one. Now again sin 2 theta is sin 2 theta cos theta, 2 sin theta cos theta, its square, that is 4 sin square theta cos square theta minus 4 sin square theta as it is, divided by this is 2a as it is. Now take square root of 4, we get 2 common from numerator and cancel with this denominator 2. Here one sine also gets cancelled, here sin square gets out from the root, we get sin theta common from the numerator and cancel with this 1 sin theta in the denominator. We get cos theta is the remaining first term of the numerator, plus minus cos square minus 1 divided by this sin theta. We know cos square plus sin square is 1, therefore cos square minus 1 is minus sin square theta. Again take minus root 1, take separate, and sin square theta, root of sin square theta is sin theta divided by this sin theta as it is. Now separate out this sign, we get put the value of root of minus 1, we get I, rest of the things are as it is. Now in this way we just find out the root of this equation, that is z. Okay, and this is a quadratic equation, that's why it has two roots, and it is given that alpha and beta are the roots. Therefore 1 plus sine, take plus and 1 minus sine as a two roots, that alpha, that is cos of theta plus these terms, and beta is take just minus. These are the given two roots of this equation. Now consider what we have to prove, alpha raised to n plus beta raised to n. Now alpha raised to n is equal to this alpha raised to n. Separate out numerator and denominator, we get this bracket raised to n divided by sin raised to n theta. Now according to Morris theorem, apply Morris theorem here. This n attached to this angle, we get cos n theta plus I sin n theta divided by this as it is. This is alpha raised to n, and similarly beta raised to n is just replace plus by minus sign. Now consider this LHS sign, alpha raised to n plus beta raised to n, we get this term alpha raised to n plus this beta raised to n. Denominator is same, combine these two, and in the numerator plus I sin theta and minus I sin n theta gets cancelled, and cos terms becomes 2 times cos of n theta divided by sin raised to n theta. This is equal to cos of n theta as it is, and sin 1 upon sin is, we know, cosec raised to n theta. This is what we have to prove. Okay, now consider the next example. Given alpha is 1 plus I and beta is 1 minus I, and cot theta is given 1 plus x. What we have to prove? This one bracket is x plus alpha raised to n plus other bracket x plus beta raised to n is equal to 2 cos n theta cos x to n. Now what we have to prove? This term. In this term x is unknown, alpha is given, beta is given, but x is unknown. We have to find out x from this equation first. Therefore cot theta is equal to 1 plus x, this is the given thing, therefore x is equal to cot theta minus 1. Therefore consider the first term x plus alpha, that is cot theta minus 1, that is x value, plus alpha value is 1 plus I, upon 1 plus 1 minus 1 gets cancelled, value of x plus alpha becomes cot theta plus this I. Now consider x plus raised to n. Similarly, we can find out x plus beta also, that is cot theta minus 1, and plus beta value is 1 minus I. This becomes cot theta minus I, plus 1 minus 1 gets cancelled. Now consider this term raised to n. Therefore x plus alpha raised to n becomes this cot theta plus I raised to n. Now put the value of cot, because we have to, if you were to prove, if you were to use Morris theorem, we have to convert cot into sine and cos. Therefore cot is cos theta upon sine theta plus I as it is. Cross multiply, we get cos theta plus I sine theta upon sine theta. Now separate this indice to each numerator and denominator, we get cos theta plus I sine theta raised to n is equal to sine theta raised to n. Now again by apply Morris theorem, what we get? Cos n theta plus I sine n theta as it is. This is x plus alpha, the one of the term of what we have to prove, the LHS side of this example, x plus alpha raised to n. Similarly, x plus beta, this raised to n, if we derive this as it is, we get just replace plus by minus sign. This is x plus beta raised to n. By observing these two, if you add these two, we have to prove that addition, take addition of above two terms, what we get? The denominator is same as it is. In the numerator, plus I sine n theta minus I sine n theta gets cancelled. Cos terms are 2 times, there's 2 cos n theta as it is, divided by denominator as it is sine raised to n theta. And this 2 cos n theta as it is, and sine 1 upon sine is again cosec raised to n theta. Indice is same because 1 upon sine is replaced by cosec. Now next example, if alpha and beta are the root of the equation, this is a quadratic equation, x square minus 2 root 3x plus 4 is equal to 0. This is given thing, alpha and beta are the roots of these two roots of this quadratic equation. What we have to prove? Alpha cube plus beta cube is equal to 0. By earlier method, just find out the roots of this equation by same formula. What we get? One root is root 3 plus, you can see here the simplification, one root is root 3 plus I alpha, that is we call alpha, and other root is root 3 minus I. Same procedure that we have already used in earlier example. Okay, now this is alpha, this is beta, this is two roots of this equation. Now consider what we have to prove, alpha cube plus beta cube. Therefore alpha is this. If you alpha raised to cube is there, therefore we have to use Morris theorem over here. For Morris theorem, we have to convert this Cartesian form into, of course, polar form in terms of cos and sine theta. Therefore consider first number root 3 plus minus plus I. For beta, we can write it similarly as alpha. Now this is x. We know the polar form of this complex number is r cos theta plus I sin theta. We have to just find out r value and theta value. Theta value depend on the quadrant, or you can calculate as in the calc also. Now consider this is alpha, first number, complex number. R value is, we also know, we already know this definition, under root of real number square upon plus imaginary number square. Root 3 square is 3 plus 1 square is 1, 3 plus 1 is 4, root of 4, take a positive sign, r value is 2. Now theta is tan inverse, this is the number in the first quadrant, therefore theta value is tan inverse y upon x, that is tan inverse y is coefficient of I is 1 upon x value is root 3, and this we can calculate by calc, you get pi by 6 answer. Theta is pi by 6. Okay, it must be in radian. Okay, now therefore this Cartesian form can be converted to polar form, that is r is 2 cos of pi by 6 plus I sin pi by 6. This is first number, we are just converted into from Cartesian to polar form. Other number is beta, which is just a complex conjugate of this alpha. Therefore there is no need to derive all these things for beta also. Just replace positive sign by negative sign here. We get the beta as it is. This is a one root, that is the other root, alpha and beta. This we get in a polar form. Now consider alpha cube plus beta cube. Here alpha cube is this bracket cube plus beta cube. 2 cube and 2 cube is common, take outside. Here 2 cube is 8, and cos pi by 6 raised to this black bracket raised to 3, and this bracket raised to 3. Take use de Morris theorem, we get this 3 inside attached to this angle, we get cos pi by 6 into 3 plus I sin pi by 6 into 3. This 2 cube as it is. Again same here, apply de Morris theorem. From the both terms, 2 raised to cube, that is 8 is common, and this 3 2 is a 6 cos pi by 2 plus I sin pi by 2 plus again this is 8 cos pi by 2, just replace by minus sign I sin pi by 2. Take common 8 and these 4 terms get add, and this 4 terms sign gets cancelled and cos term gets 2 times. This 8 as it is, 2 times cos pi by 2. We know cos pi by 2 is 0, therefore RHS side we get 0. Now consider next example. We have to prove that 4nth power of this complex number, that is, if you take the indice of this complex number raised to 4n, the answer must be minus 4 raised to n. Okay, now it is a 4n. If you want to take a power of a complex number, we have to use de Morris theorem. Therefore, for that, the particular complex number we have to first convert it into Cartesian form, and after that Cartesian form converted into polar form, then and then only we can take the power. Okay, first consider this number as it is, 1 plus 7i upon 2 minus I raised to this square. Expand this square as normal bracket, a minus b bracket square, that is a square, 2 square, 4 minus 2ab, that is 4 minus 4i plus b square, that is I square. Again I square we know minus 1, therefore 4 minus 1 is again numerator as it is, 4 minus 1 is 3 minus this 4i. Now if we want to convert this number into simple complex number, then we have to multiply, as we discussed earlier in so many examples, multiply numerator and denominator by the complex conjugate of the denominator. What is the denominator? 3 minus 4i. What is the complex conjugate of that number? Just replace minus by plus sign, we get 3 plus 4i. Just multiply numerator and denominator by this factor, we get numerator multiply throughout this two bracket, we get this numbers 1 into this and 7 into all those things, and denominator a minus b and a plus b, that is a square minus b square formula. A square is 3 square minus as it is, b square is 4i square, that is 16i square. Again we know I square value is minus 1, therefore this becomes plus 9 plus 16, and this is again I square minus value 3 minus 28, and 4 plus 20i, these two terms are same, 25i. Again this is minus 25 plus 25i divided by 19, 9 plus 16 is 25. Separate out, take a common 25 and cancel with this denominator, we get simple complex number minus 1 plus minus this 25 gets cancelled, I plus I. Okay, what we have done, just we simplify this complicated complex number into simple complex number. Okay, now what we have to do, just we have to convert this complex number into polar form. Again by earlier method, polar form is, consider this polar form, minus 1 plus I is equal to r cos theta plus I sin theta, where r value is under root of x square plus y square, that is 1 square minus 1 square is plus 1, and again 1 square is 1, that is root 2, and theta as it is lies in second quadrant, we know value of theta is pi minus alpha, what is pi minus tan inverse of y upon x, that is 1 upon 1, and tan inverse 1 is pi by 4, you can calculate by calc also, and again pi minus pi by 4, take a cross multiplication, we get 3 pi by 4. In this case theta becomes 3 pi by 4 and r becomes root 2, therefore this complex number has a polar form r, that is root 2 cos of pi 3 pi by 4 plus I sin 3 pi by 4. This is polar form. Now what we have to prove, take 4nth power means indice of this number, Therefore consider this minus 1 plus I raised to 4n. This is 4n power means raised to 4n. This is equal to this polar form as it is raised to 4n. Now separate, this is multiplication, root 2 into this bracket, therefore indice comes to both of the term. We get root 2 raised to 4n and this bracket raised to 4n, and apply here the Morris theorem. This 4n comes inside the angle, multiply this with this angle, therefore this is a root 2 again, 2 raised to half, this is 4 raised to n. Calculate, you can calculate it by calci also, and this 4 gets cancelled, 3 pi n or 3n pi, and I sin same angle 3n pi. Again apply de Morris theorem reverse, we get here 3 number we can put in the reverse manner as a n number as a indice. This is by de Morris theorem. We can either we can use either way of the de Morris theorem in any example. Therefore cos of this becomes, this bracket becomes this as it is, cos 3 pi plus I sin 3 pi, and we know cos of 3 pi is minus 1. You can calculate this by calci also. 3 pi is a 180 degree. If your calci is on degree mode, you have to put pi is not that pi 3.14, it is just a angle which is 180 degree, that we have to put in the calci cos 3 into 180. The value is minus 1 and sin 3 pi is 0. Therefore minus 1 raised to n is remaining, and combine these two term because indice is same, therefore the answer is minus 4 raised to n. That is we have to, what we have to prove. Okay, now consider this. If alpha x r, x raised to, it is x raised to r, is equal to cos pi upon 2 raised to r plus I sin pi upon 2 raised to r. Okay, we have to prove that first number x1, x2, x3, that is these are suffixes. We have to put values of this r, it is 1, 2, 3 and so on. We can put values of r. Okay, here what we have to prove first, multiplication of these two is x from starting from x1, x2, x3 and so on is minus 1, and second what we have to prove, add in the in above multiplication, just add the x naught is just get added. The difference between these two is just x naught is extra there in the multiplication. The value of this is plus 1. We have to prove. Okay, now consider first, given xr is cos pi upon 2 raised to r, put value 1, r value is 1, 2, 3 and so on. We get x1 is cos of pi upon 2 raised to 1, that is cos 2 pi by 2 plus I sin pi by 2. Put value r is equal to 2, we get cos pi by 2 square plus I sin pi by 2 square. Put r is equal to 3, we get cos pi by 2 cube plus I sin pi by 2 and so on. Okay, just for sake consider only 3 terms. Now take multiplication of these 3 terms, or with infinite number of terms. We get x1 into x2 into x3 up to infinity. It is up to again infinity. Okay, therefore now as we already seen that this is one bracket, cos theta plus I sin theta, and thetas are only different, and cos and sin I is same up to infinity. Therefore by one result we know that angle get added. Multiplication of these brackets means just addition of these angles. Therefore cos of this all angles, pi by 2 plus pi by 2 square, again pi by next term is pi by 2 cube from x cube and so on up to infinity, plus I sin addition of all these same angle up to infinity. Okay, now consider this angle separate, pi by 2 plus pi by 2 square plus pi by 2 cube and plus up to infinity. Take pi by 2 common from each term, we get pi by 2 outside. First term is 1 plus pi by 2, take if you take pi by 2 common from this all this term, we get 1 in the numerator everywhere, and here 1 2, that is 1 by 2, here 1 upon 2 square, 1 2 get outside and so on. and this is nothing but the GP, geometric progression, and this is one formula like this. In geometric progression, that is GP, A, if GP is like this, A plus AR square plus and so dot dot so on, it is an infinite term where A is a first number, okay, and R is a common ratio which is present in each term. In this case, 1 is a first number, okay, and common ratio which is present in every term is 1 by 2 only. By this, if in this GP the sum of infinite terms is by comes through by this formula, A upon 1 minus R. Here A is 1, R is half. Therefore answer is for this term 1 upon 1 minus half. 1 minus half is half, and take 2, this 2 comes to numerator, cancel with this 2, answer is only pi. Okay, therefore this addition becomes pi, and this is also same, therefore this number becomes cos pi plus I sin pi, and we know sin pi is 0 and cos pi is minus 1. Therefore in this way we just prove the first bit. Now consider the second bit. In second bit there is only extra term is there, x naught, to above series. Therefore we don't need to prove all these things, just multiply above this term into x naught by x naught. What is x naught? What do you mean by x naught? Just replace r by 0. We get pi upon 2 raised to 0. Here also pi upon 2 raised to 0. This is the term x naught. This is x naught. The rest of the terms x1, x2 are same as earlier. Okay. Now what? Again by same bracket formula, cos of addition of all these angles. First term is changed here, pi by 2 raised to 0 is there, plus pi by 2 plus same, rest of the terms are same. Now consider this addition like above. What we get? Pi by 2 raised to, take common, pi upon 2 raised to 0 is, anything raised to 0 is 1, and rest of the terms are as it is. Take pi common from the terms, all terms, we get first term becomes 1, second term becomes pi by 2, pi is only common, third term is pi by 2, 1 by 2 square, plus and so on. Again by this formula, this addition is 1 upon 1 minus half. It is a geometric progression whose first term is a and common ratio is half. Okay. Now again 1 minus half is half, this 2 comes in the numerator, we get 2 pi. In this case the addition of all angles in this equation is 2 pi. Therefore this equation becomes x naught, x2 up to x infinity becomes cos of this 2 pi plus I sin 2 pi. And we know cos 2 pi is plus 1, sin 2 pi is 0. The answer becomes 0. Our answer is 0. Okay. These are some homeworks. XR, the same example. Slight difference is there only. You can solve it by your own. And this is other example. This is also very easy. Okay, this is also homework. You can try at home. Now consider next example. Evaluate this term. We have to evaluate or simplify this term. Okay. Now consider 1 plus, as it is the term 1 plus sin alpha plus I cos alpha upon 1 plus sin alpha minus I cos alpha raised to n. Okay. If we have to if we want to apply De Morris theorem, De Morris theorem is applicable for those term in which cos alpha plus I sin alpha is there, not sin alpha plus I cos alpha. Okay, sin should be attached to I, not cos. If cos is there, we have to convert it into sin by using formula. Okay, now second step is just convert this. We know sin pi by 2 minus theta is cos theta. cos pi by 2 minus theta is sin theta. Therefore put value this one as it is, put this value sin alpha as cos pi by 2 minus alpha, and cos alpha is sin pi by 2 and minus alpha. Similarly in the denominator also. Okay, now consider this first two terms, 1 plus cos of this angle. We have one formula, cos square theta is 1 plus cos 2 theta upon 2. Therefore 1 plus cos 2 theta becomes 2 cos square theta. Okay, now here 1 plus cos, it is not double angle, it is single angle. Therefore 1 plus same formula becomes for single angle 2 theta, here theta, it becomes theta by 2, right? Just half the angle. Okay, now use 1 plus cos theta is equal to 2 cos square theta by 2 formula here for these two terms only. These two terms as it is, 1 plus cos theta, this whole terms becomes your theta. The value is 2 cos square theta by 2. It is equal to 2 cos square this theta upon 2 means by 2. Plus remaining term same. Here also denominator is same, just plus and minus is difference only. Now what in the numerator, this we use one formula here. Now consider this. Here this angle becomes half. Okay, this way half and take outside inside the, you can take half inside this angle or take put it as it is outside the angle. And now this use we have to convert this sine again into half angle, because this angle now is different from this angle. This is for De Morris theorem we can't apply until and unless angles must be same. Therefore here also we have to prove we have to use one more formula, that is sine 2 theta. We know it is 2 sine theta cos theta. We want sine only theta. Therefore sine theta becomes 2 sine theta by 2 cos theta by 2. Again the make angle half. Okay, now use this formula here. What we get, sine this I as it is plus as it is I sine theta becomes 2 sine theta by 2 cos same angle theta by 2. For by 2 take half for convenience. Okay, similarly apply in the denominators. These are the only two important steps in this example. Okay, now what is next step then? Here this is first term plus this is second term, this is term first term minus the second term. 2 is common from the both term, take outside, cancel throughout the numerator denominator. Cos is also common, 1 cos gets outside. Here also 1 cos gets outside. What we get? 2. Here power is n, therefore 2 take common, raised to n take outside. 2 take common, raised to n outside. Again 1 cos raised to n outside. From denominator again cos raised to n outside. These are similar terms, gets cancelled with each other. Okay, what is remaining in the bracket? 1 cos, 2 gets cancelled, 1 cos is there, plus I 2 cancel, sine is there, cos gets cancelled. And in the denominator just replace plus by minus sign only, we get the same term. Okay, again and raised to n as it is given in the example only. Okay, now if we observe this example, we convert it into cos plus I sine, which is applicable to De Morris theorem. Now take n inside to this angle by De Morris theorem. What we get? Cos of n into this angle plus I sine n into this angle divided by, similarly denominator is same, just replace plus by minus sign. Again what we have to do, take this denominator in the numerator as inverse. Therefore this numerator as it is, and denominator, this denominator raised to minus 1. Just take in the numerator. Okay. Now what we get? This is the numerator plus into, again apply de Morris theorem here for this inverse. This minus 1 comes into the inside the angle, and for angle cos of minus theta is plus cos theta, cos remains same, earlier term as it is, plus sine of minus theta is minus sine theta, therefore this minus becomes minus minus plus. Okay, therefore these are two brackets, of cos theta plus I sine theta into cos of other angle plus I sine theta. Now again by earlier formula, these two brackets, multiplication of these two brackets becomes cos of addition of these two angles plus I sine addition of these two angles. Okay, now what is this addition? N pi by 4, n pi by 4 minus n alpha by 2, n alpha by 2. These are the same terms, therefore this becomes 2 times n pi by 4, that is n pi by 2. And this becomes minus 2 times n alpha, 2 gets cancelled, n alpha. And angle is same, therefore sine is also same, sine of this angle is also same. This we just simplified form of this complex number. Evaluate means just simplify. Okay. Okay, now consider this example. Like for this example, you can have this homework, try at your home. Now consider this next example, simplify. It's the most easiest example of this chapter. Simplify this term. What is this term? Example, numerator denominator is there, 4 brackets are there, and 4 brackets consist of cos and sine terms, that is de Morris theorem again, and powers are different. This bracket raised to 7, this bracket raised to minus 5, divided by this bracket raised to 12 into this bracket raised to minus 6. This we have to simplify by de Morris theorem, of course. Now consider this. By de Morris theorem, what we have to do, just make all the indices or all the angles of each brackets, we have to do it similar or exactly same. For this bracket, by de Morris theorem, take 2 on the indices. What we get? 7 2 is 14. Angle becomes theta. Here take 3 to the indices. 5 is a minus 5, 3 is a minus 15. Angle becomes theta. Here take 4 on the indices. 12 4 is a 48. Angle is simply theta. And here minus sign, with minus sign we have to take that number into indice. We get this plus, and 5 into 6, that is minus minus plus, 6 5 is 30, plus 30. Angle is same. If you observe this step, each bracket is similar. These 4 brackets are same. Therefore take common bracket, this 14 in the numerator minus 15 in the denominator, numerator also, these numbers as it is, but 48 and 30 these are the in the denominator, therefore this gets in the numerator in the reverse manner, that is minus 48 and minus 30. Now add these 4 numbers, we get minus 79 of this cos plus I sin theta bracket. Again apply de Morris theorem, minus 79 comes to theta. We get cos of minus 79 theta plus I sin same angle minus 79 theta. Again we know cos of minus theta is plus cos theta and sin of minus theta is minus sin theta. Therefore this minus sign comes outside. This is the simplest form of this complex number. by using only de Morris theorem. This is our example. Okay, this is the most important example. In every exam it is asked. Okay, now you can try this homework by your own.